practicing safe dose range questions using dimensional analysis. So looking at this question here, the doctor has ordered 400 milligrams of amoxicillin, POBID. The safe dose range for amoxicillin is 30 to 60 milligrams per kilogram per dose. The patient's last recorded weight was 15 kilograms. Calculate the safe dose range and determine if the medication is safe to administer. Round to the whole number. So we have to do a couple of different problems in this question to be able to get our answer. First, we're going to look at the low milligram dose. We have a range right here, and we're going to solve for low and for high. So we'll start with low first. So over here, we're going to have low milligrams. I like to label mine like this so that I don't get confused on which one's my low, which one's my high. So if we know we're solving for low milligrams, we have to put milligrams on top. So I'm going to put my milligrams unit right there. And I'm looking at my problem. I'm going to use my low range because I have 30 and 60 milligrams, but I'm solving for low. So I'm going to use 30 first. 30 milligrams. Then I have to figure out what its sister is. Well, 30 milligrams, here's that little dash that connects my milligrams and kilograms. Kilograms is the sister. If you don't see a number here, remember that there's a secret hidden 1 right there, and that's the number we need to use. So we have 1 kilogram. Well, if we have kilogram on the bottom, we have to put kilogram on top. So we have kilograms on top. Where else in our problem do we have kilograms? 15 kilograms. So we're going to put that on top. We don't really need to do anything else because the only other number I have is my 60 milligrams, which will be in my high dose. And then there's 400 milligrams up here, but I'm not using this till the end of the problem. This is what the doctor ordered. I'm just trying to solve for the safe dose range right now. So I'm done, I'm ready to go. I can mark out my kilogram units. I've got milligrams left and I'm solving for milligrams. So first I'm gonna see what 30 times 15 is. Times 15, so we have 450 over 1, so we have 1 here. So we have 450 milligrams. So that's my first answer, my low. So then when I'm solving for my high, I'm going to be going kind of the same way. So we're going to write high milligrams. Looking at my problem for milligrams because that's what I have to start off with. So that's what I'm solving for. We're going to use my 60 because that's my high range. 60 milligrams. Its sister is still the same, that 1 kilogram. And then when I'm looking for kilograms to be on the top here, I'm using my same weight, 15 kilograms. So then when I multiply 60 times 15, so 60 times 15 is 900. And it's over 1, so we get 900 milligrams. So we have 450 milligrams and 900 milligrams. That is our range. Now that we have our range, we have one more thing left in this problem. We need to see if the dose that the doctor ordered is safe. So we look back up at the question again. The doctor has ordered 400 milligrams of amoxicillin. So now looking at my range, 450 milligrams and 900 milligrams, a way to be able to see if our medication that is ordered is in the safe dose range, if you have trouble looking at these two numbers and determining it, is you can draw a number line. So we have a number line here. We have 450. Let me do that again. So to be able to determine if our dose is safe, we can do a number line if we have trouble just looking at it and determining it. So I'm going to draw a number line here. We'll start with 300 and 1,000. Those are numbers that are way beyond these two. So then we'll do 400, 500, 600, 700, 800, and 900. And now I like to determine what my safe dose range is. So I have 900 and 450. We'll put 450 right here. We've got 900 already. And then if I draw my range right here, this is all safe. This is safe. So then when I'm looking back at my problem and I'm seeing the doctor order 400 milligrams, 400 milligrams is right about here, which is out of my safe dose range, which means that it is unsafe. So I have, my answers are 450 milligrams, 900 milligrams, and the medication is unsafe. Those are my three answers.
So here's another safe dose range problem. And we're going to give you some time to look at it and work it out, and then we'll review the answer together. Okay, now that you've had time to work this problem, let's do it together. Okay, so your patient has a headache and the doctor has ordered ibuprofen 450 milligrams. The recommended safe dose range is 5 to 10 milligrams per kilogram per dose, and they weigh 100 pounds. So we're going to calculate the safe dose range and figure out if what the doctor ordered is safe. So first, remember we need to solve for our low milligram, the lowest amount that our patient can receive and have that ibuprofen still work. So we're going to solve for low milligram. And remember with our dimensional analysis rules, whatever we're solving for has to go on top. So we put milligrams here. Our safe dose range starts at 5 milligrams, so that's what I'm going to put for my low milligrams. Now I need to figure out what partner or sister goes with it, and it's per kilogram. So 1 kg goes on the bottom. I know that whatever's on the bottom needs to go on the top. All right, so I'm gonna find whatever I have in kilograms in my problem. Well, it turns out I don't have kilograms when I look back. Instead, I have my patient's weight in pounds. So whenever we don't have a unit that we need to do the conversion, okay? So I need to change kilograms to pounds, and I know from previous conversions, from what I've learned, that 1 kilogram is equal to 2.2 pounds. Okay, so that gets rid of my kilograms, but I still have pounds on the bottom. I need to get rid of that unit, so it needs to go on top. I'm gonna look back at my problem. My patient weighs 100 pounds. So that's what I'm gonna put right there. So now my pounds cancel as well. All that's left is milligrams, and that's what I'm solving for. So I'm gonna go ahead and solve. 5 times 1 times 100 equals 500, divided by 2.2. So 500 divided by 2.2 gives me 227.27. Looking back at what I need to round to, it says to round to the 10th. So that gives me an answer of 227.3 milligrams. So that's my low milligrams. That is the smallest amount that my patient can receive. Now I'm going to do the same thing, but I'm calculating for the high milligrams. Okay, so I set this up the exact same way I did before, only now instead of plugging in my 5 milligram, I'm going to use my 10. So 10 milligrams goes on top. Again, the partner that goes with it is 1 kilogram. I want to put kilograms up top, but I don't have it in my problem, so I'm going to add my conversion in. 1 kilogram is equal to 2.2 pounds. Kilograms cancel. I need to get rid of pounds. Put pounds right up here, and my patient weighs 100 pounds. So we essentially did the same equation twice, just once using the low and once using the high. So I'm ready to multiply. 10 times 100 is 1,000, divided by 2.2. So 1,000 divided by 2.2 gives me 454.54. Again, I'm going to round to the 10th, so that's going to give me 454.54. 5 milligrams. And that is my high number. So this tells me the smallest amount my patient can get and their headache will still go away. If they get any less than that, ibuprofen's not going to work. This tells me the most that my patient can have of ibuprofen. If they get any more than that, then it's gonna be toxic for them. It's like an overdose. So I'm gonna look back at what my doctor ordered. They ordered for 50. So again, if you have trouble figuring out if that fits in your range, I don't want to go below my low or above my high. If it's hard to see that just looking at the numbers, draw your number line. Okay, so here's our number line. So right here is our low, 227.3. Up here is my high, 454.5. And everything in between those two is considered safe. So looking at 450, where would 450 fit in? Well, 450 is close to our max, but it's still less than that. So it fits right about here on our number line. So it is between these two numbers. So since it falls within our range, that means our third and final answer is safe. So to answer this problem, you would fill in all three of these numbers. Low milligram, 227.3. Our high milligram is 454.5, and the ordered dose is safe.